Yeah, good evening everyone. In the last video, we had a very clear discussion about, sir, which one? Linear probing. Okay, what is mean by linear probing? How we can able to insert the objects into hash table by using this linear probing? We have discussed very clearly in the last videos. Sir, there is some problem in linear probing. How you can able to solve that probing? How you can able to solve that problem? By using this quadratic probing, we can able to solve this issue. We will see how you can able to solve this problem by using this quadratic probing. Okay, by using this actually linear probing that we did last time was wrong. We are not inserting an items in linear order. No. Linear in the sense, don't feel that continuation. It is linear in the sense, something like maybe first element, or if the room is not vacant, next element, or two steps like that we can do. That is also linear. Okay, are you getting, Vishal? No, that we can follow in any order. So if you want to write immediately next to that, we can take index plus one. This way, this way we can solve. Are you getting my point? Yeah, that's what. Okay, right. So coming to this quadratic probing. Okay, what is mean by this quadratic probing? In the case of linear probing, we have used compute one function. Okay, compute one function by taking index value as an input, and what we returned that index value as it is we return. Now we can take quadratic probing. In the quadratic probing, what we are doing here is I will write some other function like a compute2, which will take some index value, and what it is going to take here is index into index. That's all. Beyond that, nothing. Okay, we are going to multiply index into index. That is a square type quadratic equation like that. Okay, so we are going to store the data, and remaining operations are as usual same. Okay, whatever operations that we have done in the linear probing, the example is also same. The only difference is nothing but we have to change that particular, which one, compute function, we have to change it. Except that remaining things will become same. Now let us see here. Sir, compute one is there, right? I will replace with the compute two. Sir, in the integer, sir, return index into index. So this one is what? This one is nothing but quadratic probing. Like this we have. Okay. So beyond that, nothing. Beyond that, nothing. Everything will be same. Everything will be same. But we will see first of all diagrammatically how it is going to work. Then we will go for execution process. Okay. Sir, what objects we need to insert here? I will take the objects like, okay, I want to insert 5. I want to insert 15. 15, and then I am taking 25. Let us insert these three objects. So we are going to create a hash table with the size 10. 0th location. So first location, second location, so third location, fourth location, so fifth location, sixth location, seventh location, eighth location, ninth location, like this we have. And this one is nothing but 0. So 1, and then 2, and then 3, 4, so 5, 6, 7, 8, 9, like this we have. Sir, what are the objects that we are trying to insert? So we need to insert the first 5. So what is the first activity? We are going to check a proper room is available for that or not. Okay. H dot add function is there, right? Add or insert? What function we have taken? Yes, add function is there. So h dot add of, I'm going to add 5. So let us check where it will be added. Add a function compute, it is going to take, so compute is going to return, so value percentage size. Okay, so here what is that compute one is going to return is nothing but a hash code. Your hash code will become, so 5 percentage, what is the table size? 10. So where we are going to get 5. Okay, sir, is that a vacant position is there? Yes, fifth location is vacant, so we can insert 5. Immediately it will terminate. Now second, I want to insert the object called 15. So if you want to insert the object called 15, what we have to do? So your hash code for 15 I am calculating, so your hash code will become, so 15 percentage 10. So what output we are getting? 5, right? So 5. Sir, is there any vacant position for this 5? No. So already this particular element is filled, right? Already this particular location is filled. So what it is going to do? Okay, sir, this location is not -1. So hash code will become, so hash code will become, your hash code is equal to, so previous hash code. What is the previous hash code? 5 plus, sir, what is the next one? Compute 2 we are going to call by passing I value. Sir, compute 2 is going to return index into index. So what is the I value? Here I value is equal to 0, right? So 0 into 0 will become 0. Again we are going to get 5. Sir, 5 percentage 5 means, sorry, 5 percentage 10 means we are getting 5 only. Sir, is that vacant position is there? No. Then I is equal to 1. So hash code is equal to, so 5 plus, so 1 into 1, which will become 1. Sir, which is nothing but 6. 6 percentage 10. Sir, what output we are going to get? 6. Sir, is the sixth location is vacant? Yes. There we can insert 15. Now, sir, this one got filled, right? Okay. Now let us check these two values are properly filled or not. Let us execute this code and we will check. Have you observed fifth location and then sixth location? Okay, fifth location got a filled and the sixth location got a filled, right? Correct approach. Now, what is the next one? I want to insert 25. So first we need to calculate a hash code. Your hash code will become, so 25 percentage 10. So your result will become 5. Already fifth location is filled. Now what will happen? You need to take, so I value is equal to 0. Then your hash code will become, so previous hash code a plus, so 0 into 0, which will become 0. Okay, so 5 percentage 10. So again it is nothing but 5. Sir, it is filled, right? Yes. Sir, now I is equal to 1, I am checking. Sir, your hash code will become, previous hash code is a 5. So plus 1 into 1 will become 1. So 6 percentage 10. Sir, what is the result? 6. Already it is filled. Sir, now I will become 2. Okay, your hash code will become, so previous hash code is a 6. 6 plus 2 into 2, so which will become 4. So 6 plus 4 means 10. So 10 percentage 10 means we are getting 0. Is the 0th location is vacant? Yes. So here 25 will be inserted. Let me check, is that 25 is properly inserted or not? Have you observed? So now I want to add, sir, 35. Where this 35 is going to be added? Let me cross check. Have you observed 35 got inserted at ninth location? You try to calculate, sir. You try to calculate for inserting 35. Okay, this is homework for you people. So where we can insert this 35, you calculate. Now I need to insert a 45. Sir, is that 45 is going to be accommodated? Let me check. Sir, 25, 5, yes. 45, there is no place for this, I think so. So 45 is not going to work. If you want, you can check. But let me check. 25 is located at first location. Fifth location 5 is there. Fifth location 5 is there. So sixth location 15 is there. Ninth location 35. Now let me check. Even though there is a space, we can't accommodate this 45. Let me check. So hash code will become, so 45 percentage 10 will become 5. Right. Sir, now I is equal to 0 we have to take. So your hash code will become, so what is the previous hash code? 5 plus 0 into 0 will become 0. Sir, your result will become 5. Sir, already it is filled. Okay, filled. There is no place. Now I will become 1. So your hash code will become previous hash code plus 1. That is nothing but 6. So 6 percentage 10, 6. Sir, the value is already occupied. Now I will become 2. So H code will become, so 6 plus 2, okay, 6 plus 2 into 2, that is nothing but 4. So 10 percentage 10, what will be the value? 0. Sir, it is already occupied. Okay, hash code will become, sir, previous hash code is 0. So plus, right, 0 plus 3 into 3, which is nothing but 9. Okay, sir, which is nothing but 9 percentage 10 means 9. Sir, is it filled? Yes, there is no vacant. Now I will become 4. Your hash code is, so 9 plus 4 into 4, 16. Sir, it will become 25. So 25 percentage 10 means again 5. There is no place. Even if you calculate for 5, there won't be any place. Even if you calculate for 6, there won't be any place. Seventh iteration, no place. Eighth iteration, no place. Ninth iteration, no place. That's all the possible cases we verified. So even though there is vacant rooms, because my compute function is not working properly, it is unable to accommodate the value called 45. So we can't push this 45 into the hash table. So not only in linear probing, even in the quadratic probing also, we have some issues. Okay, we have some issues that we have seen here. Now let us do some normal operations like hash table dot. I want to search for the data called 15. Sir, is this data is available? Yes, it has to return true. Let me check. Okay, sir, now after this I want to check so whether that 35 is it inserted or not. Yes, it is inserted. We are going to get it true. Sir, is that 45 is there in the list in the hash table? No, immediately we are going to get false. Okay, so I want to remove off 15. So now after this I want to take h dot print. Now what will be happening? Sir, is that element? 1 minute, 1 minute. So remove method is there? No, delete method is there. Right. Have you observed? Like this we have. So this is the way how you can able to insert the objects. I think you people got very clear clarity about this linear probing and quadratic probing. What are the problems which are available in linear probing? How we can able to solve this problem in quadratic problem? I mean quadratic probing. Is it clear for everyone? Please confirm. In linear probing, any linear equation we can use, and in quadratic probing, any quadratic equation we can implement. Yes, that is based on our requirement we can choose. That is called as algorithm design, right? We can write. See, Raja, in everything we have an issues. Okay, because if you observe carefully, my intention is to explain the problems. That's why I have taken the numbers like this. If you observe, so no one is going to take numbers like this. We know because all these will occupy same room only. Are you getting my point? So but when you are doing this, where we are getting problem, that we need to investigate. That is the reason why I have taken similar numbers. If you take numbers from 91 to 100, definitely for every number corresponding rooms will be available. Okay, but when you are having a rooms, I mean when you are having an objects with the same hash code, then how my algorithm is going to work, this is nothing but the example. Okay, so this is the worst case I am explaining. Are you getting my point? Everyone, please confirm, is it clear up to this? I request everyone to please respond. So now let us go for separate chaining and its implementation. So in collision, okay, in collision handling, so method chaining is a concept, so which introduces an additional field, okay, so called data. So that is nothing but I can say chain. That is nothing but a chain. Okay, now a separate, okay, a separate chain table is maintained. A separate chain table is maintained for colliding, okay, for colliding objects. Okay, for colliding objects. Okay, sir, now when collision occurs, so then what we are doing here, so then a linked list that is nothing but a chain, so is maintained at the home bucket. At the very beginning, we are going to take one link, sir. Okay, now I will explain with the help of diagram first how it is going to work. Later I will go with implementation. Let us take one example. So now I'm going to take a hash table like this. First location, second location, so third location, fourth location, so fifth location, sixth location, seventh location, eighth location, and ninth location. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this we have. Now let us try to insert some objects. Listen carefully. I want to insert these objects like 121. Okay. So 3, 4, 21, 61. So 24, 7, 97, 8, 9. Like this we have to take. Sir, what is the first one? 121. So what is a reminder? 1, right? So a node is going to be attached here. A node is going to be attached here. Sir, next object is 3. Where it is going to be added? So here it will identify that hash code and it will insert here. Next object is 4. Now 21. Sir, already with 1 we have an element. So it will be attached like a single linked list. It is going to be attached. 61. 24. So already 4 is going to be stored. Now that 24 will be attached here. Now 7. Sir, 7 vacant position is there. Now try to insert here. Now 97. Sir, already 7 is there. Now we need to store here 97. Okay. Sir, now 8 is there. So here vacant position is there. Try to insert. Now 9 is there. So this one is nothing but 9 we are going to store here. Like this we have. So here we have to assign null fields definitely. Otherwise we are going to get random values. So the fields which are empty, we are going to assign with null references. It is mandatory, because in the single linked list already we have seen. So this particular concept is called as separate chaining. This particular concept is called as separate chaining. Of course, we have to implement this by using single linked list. Don't worry, I will explain the program by using single linked list, how we can able to solve this problem. Can you please confirm, is this concept is clear for you people, everyone? Is this used in implementation of linked hash set? Yes. Clear? I request everyone to please respond. Right. So now we will see the implementation of this one. Let us see how you can able to do this. And all these things we need to change. Okay. So hash table, I am taking size. So I don't want to represent. Sir, if we have a duplicate values, then continuously it will be added. Linked list is going to allow duplicates, right? What is the issue with that? Are you getting Chandan? Right. So I don't want to take A. I don't want to take an array. I will take node A. Okay. So now hash table. So I'm creating a constructor which is taking size, current size, and A is equal to, in the place of int, we have to take node type. Node type. Okay. Now for I is equal to 0, I less than size I plus plus. So your A of I, we should not assign with null. We have, sorry, we should not assign with -1. We have to assign with null. But what is that node, sir? Okay. Now I'm taking integer value node. So compulsory you need to maintain next field node and integer value and node next field we have. So current next will become next. Like this we have. Okay. Like this we have. Now class node we are going to maintain. Sir, that's all. Hash table is nothing but this one. Now I need to work with a compute function. First I need to work with a compute function. So here integer value percentage size. Is there any requirement of second function? No, not required. Okay. So now I want to write add function. So integer hash code, it will compute the value, and we are not required to write this much code. Okay, very simple. I think even no need to take a boolean, because there is no case of failure, right? Definitely the object which you are trying to insert, it will be added. There is no case of a failure. Okay, so a of that hash code, a of that hash code will become, so new node of. Okay, we are passing that value, and the next field will become, so a of hash code. I will explain in the execution part. This is nothing but how you can able to add the objects. Now, sir, how to perform remove operation? Remove is a bit logical thing, sir. I will explain. First, I will explain how it is going to add. Listen carefully. Suppose consider first I want to take, okay, first I am going to take some objects like, so 13, okay, 14, so 23, so 37, like this I want to store. Sir, first what it is going to be taken? Here we have to take a list. 0th location, first location, so second location, third location, and so on. So 0, 1, 2, 3 and so on. Sir, now it will take the first value 13. What is the compute of these 3, right? So now listen carefully. What is the 3 field actually? Null, right? So your hash code, A of hash code, A of 3 will become new node. I am creating a new node here. Okay, I am creating a new node here with value and the next field as a hash code. So it will create this one. Its value is nothing but 13. And the next field is null. And this is linked, right? Like this we have. Okay, like this we have. Maybe, sir, in the reverse order, it will be there. Like this, I am going to represent. So this is the new node. Its value is nothing but 13. So what is the link? A of h code. This is nothing but null. This one is pointing here. So that we have a link. Sir, now we are getting 4. 14. 14 means what? In the fourth location, it is going to be attached. Like this we have. Now listen carefully. I want to insert a 23. First, it will create a new node with the content 23. Sir, what is the next field? A of h code. Sir, what is the h code value? For 23, it will become 3. So A of 3 is not null. This one is nothing but A of 3. So that one I am linking. Are you getting? So in the case of diagram, we are going to get in the reverse direction. That's why don't confuse. We are going to attach the nodes. Beyond that, nothing. And for 33 also, what will happen? Your hash code will become 3. So a new node will be created. What is the content? 33. What is the next field? It is pointing A of hash code. Where hash code is pointing? This one, right? So because this is the 3, so A of 3 is representing these elements. So that link will be attached. Like this, we can able to add the objects into the linked list. Hash table. I think you people got a clarity about this. Adding the values. Can you please confirm? Is it clear for you people? Everyone, please confirm. Is it clear for you people? Clear? Right. So now I want to perform which operation? Delete operation. Okay. Boolean, let it be delete integer value. We need to calculate a hash code. After that, that total story is going to be differentiated. Now, what we are going to do here is, sir, node, I am going to take one new pointer that is nothing but next node. And what is the head value? Beginning node, it will become A of hash code. A of hash code. For example, consider I have a list is there. Okay, like this, just for your understanding purpose, I am taking. Like this I have. Okay, consider only I am taking, so 0th location, and I am taking first location, and I am taking second location. So this one is attached with something like 11. Consider just for your example purpose. And this one is attached with, so 101, just for our understanding purpose. This one is attached with something like 111. And here we have 22 is there. Just consider. And I have 100 is there. Okay, so under 90 is there, which is attached to this. Now, so I want to delete which value I want to delete. For example, consider I want to delete 22. Now what will happen? Sir, what is the hash code for 22? 2, right? So A of hash code will become head. So this will become your head node, right? A of 2. This will become your head node. Now, after this, what we have to do? Sir, we need to check whether if your head is not equal to null. Yes, it is not equal to null. At the same time, so head dot value is equal to the value which you have given. Yes, my value is 22, head value is also 22. Then, so A of your A of your hash code will become, what we have to do? Sir, head dot next. And then return true stating that element got deleted. What is the head tends to next? This one next field is what? Null, right? This one next field, maybe just for your understanding purpose I have mentioned like this. So its next field will become null because this is the last node. Maybe if you want to get clarity, I will do one thing. Like this, okay? Like this we have, sir, what is the next field? Null, right? So immediately it will be assigned for this, so that what will happen? So this link by default will be gone. Here itself null field will come. This is one case. Suppose consider I want to delete. Okay, so consider I want to delete 102. This one I want to delete. Then your hash code for 101, right? 101. Okay, so 101, your hash code will become 1. Okay, right? Sir, head is equal to a of hash code. This one will become head. Sir, is it not equal to null? Yes. Is the value is the same? No. Then what we have to do? You need to come out from this until your head is not equal to null. Until your head is not equal to null, I'm going to take next node will become so head dot next. Sir, what is the next node? Head dot next. That means next node will become this one. Okay, this is nothing but next node. Sir, now what we are doing after this? So if your next node, okay, if your next node is not equal to null, yes, it is not equal to null, and next node dot value is equal to the value which you want to delete. Yes, the data is the same. Then what we have to do? Sir, your head dot next is there, right? It will become next node dot next. Then we have to return true stating that element got deleted. Sir, head dot next, this is the head. Head dot next will become next node dot next. That means this link. Now this is by default is deleted. It is already we have seen this one. Sir, if this condition is not satisfied, I mean, if this condition is not satisfied, so then what we have to do? You need to go to the next node, right? Otherwise, what will happen? Sir, your head will become next node. Okay, your head will become next node. This will become next node. Your head will become next node, and keep on. We have to move. So this is going to control while loop. Sir, even if the while loop is came out from the while loop, so these two return statements are not encountered. Then what is the meaning? The element which you are searching is not available. Then simply you can return the message saying false. This is nothing but how you can able to perform which operation? Delete operation. Sir, hope you people got clarity about this deletion of object. Can you please confirm any doubts up to this? Yes, please confirm everyone. Is the concept is clear for you people? Right. So now next operation is nothing but a search. So first, as usual, we have to take hash code. So then what is our requirement? Next one is nothing but node I'm taking head is equal to, so a of hash code I'm taking. Okay, so while your head value is not equal to null, while your head value is not equal to null, and so if head dot value is equal to value which you are going to get, if it is the same, so then what message we have to print? Return true. Okay, sir, next your head will become head dot next. We have to keep on moving. Sir, finally, if you came out from while loop and if the result is not satisfied, then simply I'm going to return false. That's all. So this is nothing but search operation. Several times we implemented this operation, sir. That's why, so not required to put more concentration on this. Okay, sir, now how to print the values? So print content of the hash table for I is equal to 0, I less than size I plus plus. We should not print directly because it is not an array. Okay, what we have to do? Sir, node your head will become E of I. Okay, so while, because every time you need to print, while your head is not equal to null. So then what we have to do? System dot out dot print. Don't use println. So your head dot value we have to print, followed by like this. Every element it is going to print. What about your head? Head will become, so head dot next. Like we have to repeat continuously. At last, after came out from this while loop, you have to print null. Like this we have. Okay, this is nothing but how you can able to do. Sir, now let us see how we are going to execute this. First, I am going to create hash table. So h is equal to, so new hash table of with size 10. Okay, so hash table dot add of, I want to add 13. So hash table dot add of 14. So hash table dot, I am not explaining all the elements cases, just you try by yourself. So add of 16 and h dot add of 19, like this I am taking. Now I want to print this list. Now let us see what will be our hash tables content. Now I'm going to execute. You can see, sir, first one is null. Next one is null, null, 13, null. So 14, null. Of course, in the first I explained the diagram, right? Like that it is going to store. First the values, at last null values, okay? Now, sir, I want to insert h dot, I want to add, so 23. Okay, h dot add, I want to add 33. So h dot add, I want to add 43. So h dot add, I want to add 333. Now see that third location, how the values are going to be stored. Have you observed a link is formed or not? Yes. So like this, we are going to work. If you want, you can ask for what you can call search operation. Like I want to search h dot. So search of, can you please search for 333? Yes, this element is available, hence we will get true. Suppose consider I want to search for 999. Okay, sir, is this object is available? No, immediately what we are going to get is false. Let us cross check. Yes. So similarly, we can perform delete operation also. So system dot out dot println of, so h dot remove, right? Remove or delete. So delete of, I want to delete 333. So that element is available. So after this, if you print this, sir, that 333 won't be there in your list. Clear, right? So that 333 got removed. You can cross check here. Is it there? No. So return type is true. Like this, we can implement separate chaining for storing these objects in your hash table. I think what is the problem with normal hash table? How you can able to resolve these collisions? How to work with linear probing? How to work with the quadratic probing? How you can able to use this separate chaining? Is these concepts are clear for you people? I think so. Right? Any doubts, friends, up to this? Please confirm everyone. Is this concept is clear for everyone? Please confirm. Right. So with this hash table concept got completed. With this, the hash table concept got completed. Okay. But with this hash table become infinite. No problem. You can control the elements, right? It is a finite. Why it is infinite? Definitely it is not infinite. Suppose consider with the same hash code, definitely you won't expect more than 100, right? But if you are storing, for example, consider I have a hash table with a size 10. So in every hash code, for every hash code, I got 100 values. So that how many values will be there in this hash table? 1000 values. Searching for an element in the 1000 values is a very difficult task. But if you are searching for an element, calculate a hash code for that. Definitely it will be any one of the numerical value from 0 to 9. So Based on that hash code, if you perform search operation, sir, you are going to search only in 100 elements, not 1000 elements. Are you getting my point? Clear? Yeah, no problem. Searching operation, see, additions, removal, those things we are not doing here. So that will be best choice for linked list. Only for search operation we can use this. Are you getting my point? Yeah, we are using these hash tables only. How can we can pinpoint duplicate elements? They're both leaves the same hash code. You need to search. You need to search in that particular with hash code. Okay, so a separate chain is maintained, right? So there we can able to do. Are you getting, Vishal? Already we have seen this in the linked list. Same approach we have to use here. But if we want to delete only one element, see, I think it will delete only one element. First occurrence it is going to delete. Our application is going to delete only first occurrence, I think so. Right, because once if we got that element, we are using return statement, right? Here we are using return. That means completely the control will come out from that. Yeah. So if you don't want to remove only first occurrence, if you want to go for all occurrences, then you can set a flag variable and you can iterate this loop. Are you getting my point, Vishal? Yeah. One duplicate element from middle. Maybe, see, in all aspects, this is not correct. Okay. Maybe some approaches, worst case will be there. We can do alterations for that. Okay. Right, sir. So remaining things we will meet for the continuation tomorrow. Okay. And sir, tomorrow maybe that bit manipulations or some pending is there, right? That I will take. And probably this Saturday I'm going to take the session. Okay. I'm going to start greedy algorithms or backtracking, like that. I'm going to start. Okay. I will inform you the timings. Probably it will be on the same times. Okay. Right. Tomorrow, maybe less time you can expect, maybe some 20 minutes that bit manipulations I need to cover tomorrow. Okay. Right, sir. Thank you. We will meet for the continuation tomorrow. And these running notes will be uploaded after 9 o'clock. And I think that video's problem is there, right? It is resolved, I think so. Please check once. Okay. Right. Thank you. Good night.